Understanding the brain, that's another biological mechanism. This is important in terms of actually fixing problems of the brain. It has other benefits. We'll actually get better tools to create artificial intelligence, better paradigms and algorithms. We'll have greater understanding of ourselves. That's been the goal of the arts and sciences for millennia. All of this is gearing up exponentially as well. We're doubling the spatial resolution of brain scanning, non-invasive brain scanning every year. We're doubling the amount of information we're getting about the brain every year. And we're also showing that we can turn this raw data into working models and simulations of the brain. There's already very good, very precise simulations running on computers of regions of the brain, like the visual cortex, the auditory cortex. This is a block diagram of the model and simulation of the auditory cortex. The cerebellum, where we do our skill formation, like catching a fly ball. We always wondered, how does a kid do that? Because you've got to solve a dozen simultaneous differential equations to catch a fly ball in a couple of seconds, and most 10-year-olds haven't taken calculus. But we actually now understand that the cerebellum does do those calculations, solves those equations subconsciously. There's simulations of the cerebral cortex. This is a slice of the cerebral cortex that has been modeled and simulated, and this is actually a picture of the simulation showing that we've captured that essential complexity. So all of this is gearing up at an exponential pace. And I'll just show this one graph on solar energy, just because people say, well, if people live a lot longer, if we're going to dramatically extend human longevity, isn't the Earth going to get crowded and we're going to run out of resources? Yes, we would run out of resources if we stuck with 19th century first industrial revolution technologies. And all of these Malthusian concerns about running out of resources are based on resources using these old methodologies, like fossil fuels. But if we use these new technologies, the same technologies that are going to bring radical life extension will also bring radical expansion of our resources. We actually are awash in every form of resource. There's 10,000 times more energy we need falling on the Earth from the sun every day, but we just haven't had a means of converting it. However, we're applying nanotechnology to solar panels, and they're becoming more efficient, and the cost is coming down dramatically. The solar energy is on an exponential rise. We're doubling the amount of solar energy every 2 years, and have been for 20 years. It's been 10 doublings, and you can see here, very smooth doubling every 2 years. And we're only 8 doublings away from meeting 100% of our energy needs, and there's 10,000 times more sunlight than we need. And there's a similar story on water, on food, housing, which I don't have time to get into, but the same technologies, information technologies that are growing exponentially, that will bring us radical extensions to our longevity, are also going to expand our resources. They're also going to make the future a lot more interesting. So as we get out to 2029, computers will be very powerful. Very inexpensive computers will match the human brain. We'll have reverse engineered the brain. We'll have mastered human intelligence in a machine, but it's not going to be an alien invasion of intelligent machines to displace us. We're actually going to merge with these technologies. We're going to put them inside our bodies and brains. And the primary application will be for our own health and longevity. We will have these devices inside our human body, keeping us healthy at the cellular level, destroying disease when it's at the level of one cell, not waiting till it gets to the level of an organ and is life-threatening. They'll go inside our brains non-invasively, and just like neural implants today, will interact with our biological neurons, but they won't require surgery. They'll get there through the capillaries. They'll interact with our biological neurons. They'll expand our memories. They'll expand our thinking capacity. We'll be able to actually think, not just with the computers inside our brains, but they'll be connected to the web. We'll be able to think out on the cloud. They'll expand human intelligence vastly. We'll be able to have direct brain-to-brain communication. We'll have new ways of getting information in and out of our brains. But it is going to vastly expand human longevity. And here's that progression I mentioned. It was not in the interest of the human species for people to live past their early 20s 1,000 years ago. There was very little food, and once you were done raising your kids, you were 23 and your kids were 12, you're just using up the precious resources of the tribe. Human life expectancy was 23. It was 37 in 1800. There was no understanding of the germ theory of disease. no antibiotics, no sanitation. So Schubert and Mozart died in their 30s of bacterial infections, and that was typical. It was 48 in 1900. It's pushing 80 today. This is from the linear progression of health and medicine, and it's been very useful. However, now that health and medicine has become an information technology, and it's now becoming fairly mature, 10 years from now, these technologies will be 1,000 times more powerful. It really will be a different era. And there's a lot of methodologies using stem cells and new forms of tissue engineering and reprogramming our genetic code in a mature individual that are entering, in many cases, the testing phase of development. These will be available protocols in about 10 to 15 years. And according to my models, 15 years from now, we'll be adding more than a year every year to human life expectancy, to your remaining life expectancy. So the goal really is to be in good shape at that time. So in order to get there, we need to use Bridge 1, and my co-author, Dr. Terry Grossman, and I have written extensively about that. We have come out with our second book called Transcend, where we talk about all the things that you can do to slow down the aging process and the disease processes right now. And there's a lot more that can be done than people recognize. A lot of the public health recommendations are compromised based on what they think people are willing to do. But if you're aggressive, even at my age, I'm 61, although I come out in my early 40s on biological aging tests, you can be confident, reasonably confident, of being in good shape 10 or 15 years from now when we get to the mature phase of this biotechnology revolution. And that will be then a bridge to the third bridge, the nanotechnology revolution. Ultimately, we'll get to a point where we can actually capture our mind file and the information that constitutes our personalities and back that up. People will think it was pretty daunting. 100 years from now, people will think it was pretty daunting that people went through the day without backing up their mind files, and just as we would think it irresponsible today that people didn't back up the information on their personal computers. So at each point in time, there's more that we can do to preserve the essential essence of who we are. So I think it's a great time to be alive. We actually can see a program where people alive today, including baby boomers like myself, can plan to be in good shape not so long from now, just 10 or 15 years from now, when we get to this tipping point, what Albert de Grey calls longevity escape velocity. And in my view, it's only 15 years away. And it's not a guarantee, even if you have a life expectancy of several decades, which will be continually expanding. You could get hit by lightning the next day. But we will change the metaphor of life from the sands of time running out to the sands of time running in. So I hope you have a great conference, and I appreciate this opportunity to share these ideas with you. Thank you.
So we want to thank Ray Kurzweil. That presentation was made specifically for this event.